Hi viewers, welcome to our channel Kavithashok Educational and Motivational channel. Today we are continuing our permutation combination topic. In the last session we discussed some important concepts: divisible by 5, divisible by 4, 3, 2 as well as 25. Now we are calculating the sum of the 4-digit numbers. So this is very important problem for annual exam. Right. Find the sum of all 4-digit numbers that can be formed using the digits 1, 3, 5, 7 and 9. So this is gunshot question for 4 marks in the annual exam. Right. Before going to solve this problem, first what he is given, what he is asking, once we will check. 5 numbers are given. By using these 5 numbers, we have to construct 4-digit number, right? First, how many 4-digit numbers we can construct, we will check, right? N value is equal to 5. We want 4-digit number, so R value is equal to 4. Number of 4-digit numbers is equal to 4 places are there, 5 numbers are there, we will fill up in 5p4 ways. So this is equal to 5p4. 5p4 in the sense starts with the 5, 4, 3 into 2, 1, 2, 3, 4, 4, 20, 60, 120, right. By using given 5 numbers, we will construct 120 4-digit numbers. But the question is here, if we write 120 numbers, find the sum of all 4-digit numbers. So we want the sum of 120 4-digit numbers. That is our question. So before going to calculate the summation, I will take one example. Look at here now. Suppose 1, 2, 3. 3 numbers are there, right? By using these 3 numbers, we want to construct 3-digit numbers. So what are the numbers? First we will get 123, next 132, next 213, next 231, next 312 and 321. Once you observe, in the first row, 1-digit places, 2 3s are there, 2 2s are there and 2 1s are there. In the same 10th position also, 2 2s are there, 2 3s are there, 2 1s are there. In the last position also, 2 1s are there, 2 2s are there and 2 3s are there. Means in anywhere, the first digit and the second digit or the third digit, 10th position or first position or 100th position, the sum value is same. Only the difference is here, face value same, place value, according to the place value, the answer will be changed. So 2 2s means 2 times of 1 we can get, 2 times of 2 we can get, 2 times of 3 we can get. In the same manner, 2 times of, again 1, 2 and 3, again 2 times of 1, 2 and 3. The difference is here, in this unit place the into 1, in the 10th place into 2 into 10, in the 100 position into 100. The summation value is same. The difference is here, depending upon the place value, unit place into 1, 10th place into 10, 100 place into 100, remain in the same concept. So by using the same concept, we will calculate the summation value. Listen carefully. Right. Now first, 4 places are there. 4 places. Why? Because 4-digit number. In the unit place, first fix 1. Now we are calculating how many 4-digit numbers are there, end with 1, right? 1 fixed in the sense 4 places are there, we will fill up with 4p3 ways. The same manner, 3 fixed, again 4p3. In the same manner, 5 fixed, again 4p3. Next, 7 fixed, again 4p3. Next, 9 fixed, again 4p3. Just we are calculating the sum in the unit place, numbers, right? Now 4p3 common, yeah, 1 plus 3 plus 5 plus 7 plus 9, right? It is in unit digit, so that's why into 1. So this is equal to 4p3 into 16, 21, 24, 25 into 1. The sum in the unit place, right? Sum in the unit place. Now, sum in 10th place. Sum in the unit place is over. Sum in the 10th place is automatically 4p3 into 25 into 10. Just the value change. In the unit place into 1, in the 10th place into 10. The same manner, 100th place, the sum in the 100th place is equal to 4p3 into 25 into 100. In the 1000 place, 4p3 into 25 into 1000. The summation value is same, fixed. Is it clear now? Only the difference is here, place value, according to the place it is increases. So, sum of all 4-digit numbers is equal to 4p3 into 25 into 1000 plus 4p3 into 25 into 100 plus 4p3 into 25 into 10 plus 4p3 into 25 into 1. So finally 4p3 is common and 25 is also common in all the cases. 1000 plus 100 plus 10 plus 1. So finally what we can get here, 4p3 into 25 into 1000, 100, 10, 1 in the sense 1, 1, 1, 1. Now 4p3, 4 into 3 into 2, 4 3 are 12, 2 are 24 into 25 into 1, 1, 1, 1. 25 2 are 50, 100, 600 into 1, 1, 1, 1. 6 1 are 6, 6 1 are 6, 6 1 are 6, 6 1 are 6, 00. Right? If we add these 124 digit numbers, the summation value will be 6,66,600. Is it clear now? Like this we can calculate the summation. But in examination, by using the direct form, we can calculate the answer. There is no need to solve all these things. Okay. Now we will discuss that thing. Right. First we will write that formula. What is given here? N value will be 5. We want 4 digit number, R value 4. Right. Sum of all R digit numbers. Sum of all R digit numbers is equal to, the formula is N minus 1 P R minus 1 sum of given numbers into 1, 1, 1, 1, so on R times. Okay. What we calculated in the last problem, we used the same thing in the formula. N minus 1 P R minus 1 sum of given numbers into 1, 1, 1, so on R times. So then how can we calculate? 5, N value 5, 5 minus 1 P R minus 1 in the sense 4 minus 1 sum of given numbers in the sense 1 plus 3 plus 5 plus 7 plus 9. 1, 1, 1, so on R times. R is nothing but 4. So 4 ones. 1, 1, 1, 1, 4 times. This is 4p3. 9, 10, 13, 18, 25. 1, 1, 1, 1. 4p3 is nothing but 24 into 25 into 1, 1, 1, 1. 25, 20 is 500, 100, 600 into 1, 1, 1, 1. 6 1 ja 6, 6 1 ja 6, 6 1 ja 6, 6 1 ja 0. 3, 2. So 6,66,600. So by using the formula, we can solve this problem. Only by writing the formula we can get 2 marks. For the simplification we can get 2 marks. Total 4 marks. Right. Sometimes along with the 4 digit, in the given 4 digit number, 0 also present. Here without 0. This is the formula for without 0. If 0 is present, then the formula will becomes very important one. Sum of all r digit numbers. Sum of all r digit numbers and 0 is present. Then the formula will becomes here. Same formula we will write first here. N minus 1 p r minus 1 sum of given numbers into 1 1 1 so on r times minus n minus 2 p r minus 2 again sum of given numbers into 1 1 1 so on r minus 1 times. So by using this formula we can calculate when 0 is present. So what is the difference when 0 is present and 0 is not present? Simple thing is there. Suppose 3 digit number is there like this. 123 3 digit number. 120 is also 3 digit number. If you write 0 1 2, the same numbers we are using, but this is not the 3 digit number, it will become here 2 digit number. So that's why there is a difference in the formula when 0 is present and when 0 is not present. When the 0 is present, n minus 1 p r minus 1 sum of given numbers 1 1 1 so are r times the same formula here minus only the difference is decreasing 1 n minus 2 p r minus 2 sum of given numbers is same 1 1 1 so our r times is there here r minus 1 times. So by using the formula easily we can get remaining 4 marks question. Right. This is important for both 2 marks question and MSET. What is given here? Find the number of injections of a set A with 5 elements to a set B with 7 elements. First we will discuss the concept. In exams no need of concept. By using the formula directly we can calculate. What is given here? 2 sets are there. A, B. A contains 5 elements and set B contains 7 elements, means I am taking blank places. 1, 2, 3, 4, 5, 6, 7 blank places. So this is a function from A to B here. Number of injections we want. Injection in the sense here, the function f from A to B is said to be injective if distinct elements of A have distinct images in B. Different elements, different images. Right. To fill this first place, how many choices are there? 1, 2, 3, 4, 5, 6, 7 choices are there. Right. So we will relate with one of this position. Okay. Right. Already it is linked with one of the element. Right. For the second one, how many choices are there? Only 6. Why? Because already 1 is related. So then 6 choices are there. If it is related to like this. Now for the third one, only 5 choices. Already 2 filled. So 5 choices. For the fourth one, 4 choices. For the fifth one, 3 choices. So number of injections defined from A to B is equal to, according to the fundamental theorem, 7 into 6 into 5 into 4 into 3 is nothing but here 7 1 2 3 4 5 7p5. This is the form. So this is nothing but 7 number of elements present in B, n of B, p 5 number of elements present in A, n of A. So in exam, just write down the formula n of B, P, n of A, replace, easily we can get the answer. So n of b, p, n of a. So what is the answer for that here? 5 4 are 20, 60, 360, 360 into 7, 0, 42, 21, 25. 2520. If you write up to 7p5 also, that is correct only. If we simplify and write 2520 also, it is correct only. So the number of injections defined from A to B is equal to n of B, P, n of A, that is 2520. Right. So one more important question. It is also important for 2 marks as well as MSET. Completely MSET bit. Right. Find the number of ways in which 4 letters can be put in 4 addressed envelopes so that no letter goes into the envelope meant for it. So actually 4 letters are there, along with that 4 envelopes are there. 4 addresses are there. Okay. For each address, 1 letter we have to put. The condition is here. No letter is kept in the envelope meant for that. So it will be occupied in the different place. That means what? That is a de-arrangement. So we are calculating the number of de-arrangement problem. So previously we calculate arrangements, and this is specially for de-arrangement. Simply I will give one example. Suppose ant is there. Okay. 3 places are there. A, the first place is reserved for A. The second place is reserved for N. And third place is reserved for T. If you write A here, N here, T here, we can get ant. De-arrangement in the sense here, the place of A is this now. We have to arrange A either in this place or in this place. N is either in this place, N in this place. T, either first place or the second place. No letter is in its consent position. That is called a de-arrangement. Here also 4 letters are there and 4 envelopes are there. We have to de-arrange that elements. So n value is 4 here. Number of de-arrangements also 4. Right. First we will write the formula. Number of de-arrangements is equal to NPR into 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial plus so on, minus 1 to the power of r, 1 by r factorial. By using this formula, we can find out the number of de-arrangements. Right. This is equal to n in the sense 4. R is also 4 here. So 1 minus 1 by 1 factorial. How much we can write? R value 4 in the sense here. Minus 1 power 4, 1 by 4 factorial. Minus 1 to the power of 4 in the sense positive. 1 by up to 4, 1 by 4 factorial we have to write. Right. 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial. Simply alternate plus minus, plus minus, plus minus, plus. Up to 4 factorial we have to write. Okay. So now 4p4 means 4 factorial. 1 factorial get cancelled. 1 by 2 factorial is nothing but 2. Minus 1 by 3 factorial is nothing but 6. 1 by 4 factorial is nothing but 24. Again 4 factorial in the sense 24. 24 is the LCM. 2 24, so 12. 6 24, so 4. 6 4 is 24. 24, this is 1. 24 get cancelled here. This is equal to 12 minus 4 is 8. 8 plus 1, 9. So the number of de-arrangements is equal to 9. So in MSET also just write down the formula and replacing the values we can get the answer. Is it clear? Thank you very much.